Hi, we are going to see how to find asymptode in the process of the sketching the curve. This is the fourth part. First, we have seen how to find the domain, intercept, symmetry. This is the fourth. Then fifth is find the interval, local. Sixth is local maximum minimum. Seventh is concavity. Okay. Please see my previous three videos to find the domain, intercept and symmetry. This is my fourth video. What is asymptode? There are three asymptode: horizontal asymptode, vertical asymptode and slant asymptode. I am going to give some techniques. Please note all the points. Horizontal asymptode. Horizontal asymptode, what is the definition? When x is approaching infinitive, when x is approaching infinitive, here when x is approaching infinitive, f of x is L. You see, when x is here, f of x is approaching one particular value, maybe y equal to 3 or 4, then the horizontal asymptode is y equal to, so for example, if it is 3, y equal to 3. When x is approaching negative infinity, the y value becomes constant, that is L, then that also horizontal asymptode. Suppose if it is 2, y equal to 2. Vertical asymptode. Vertical asymptode, when x is equal to a, when we are approaching x from the right, the y value is infinitive, it is the vertical asymptode. For example, this is the x equal to 3. When you are approaching from the right, the y value become infinitive. Y value become infinitive. It is the vertical asymptode. At the same time, when you are approaching the x is equal to a, from the left, y value approaching infinity, negative infinity, that time also it is the vertical asymptode at x is equal to 3, for example here. It is the same case when you are approaching the x from the right, the y value becomes negative infinity. Here suppose x is equal to minus 2 means this is the vertical asymptode. The same case here, when you are approaching x from the left, the y value approaching the positive infinity, it is the vertical asymptode. Okay, now see here, this is the rule. When x is approaching infinity, f of x is L. When x is approaching negative infinity, f of x is L. This is called horizontal asymptode. Note it down. Vertical asymptode, when x is when x is approaching a plus, f of x is infinitive. When x is approaching a minus, f of x is negative infinity. Okay, in the same case, this is a vertical asymptode. When x is approaching, f of x is infinity. Okay. Here also the same, another case is when x is approaching a plus, f of x is negative infinity. When x is approaching a minus, f of x is plus infinity. In the four cases, it is called vertical asymptode. Okay. Horizontal asymptode rarely will come. That also we will notice down. You note it down. Slant asymptode. Slant asymptode means when f of x, that is when y minus x approaching 0, it will be slant asymptode. We will see that example in, I will explain in my example question with the clear evidence. Okay. Now another one thing, none. When x is approaching infinity, f of x is approaching infinitive or negative infinitive, it is no symmetry, no horizontal symmetry. For example, when x is approaching infinitive, this is f of x is also approaching infinitive. So this is no asymptote. Sorry, it is no asymptote. Okay. Now I am going to illustrate with the 10 examples. With the same examples I explained domain intercept symmetry. Now we will go to the first example. Before that, note it down some points. When e power x is coming, the asymptode is horizontal asymptode y equal to 0 will come. And ln x is there means x is equal to 0, vertical asymptode will come. E power x is what? Like this. Ln x, vertical asymptode will come. And 1 over x is vertical asymptode, x is equal to 0 will come. 1 over x is. And another some simple points. When you find the domain, if you find suppose x minus 3, when you find the domain, when x is not equal to 3, in that case it will be the vertical asymptode. That point also note it down. Okay, now we will go to the examples. X cube plus x. There is no asymptode, none. Because when x is approaching infinitive, you put the infinitive value, f of x is also approaching infinitive. When x is infinitive, f of x is also approaching infinity, so it is there is no asymptode, none. Question number 2, x minus x squared minus 3x plus 2. I already told you if it is fraction, horizontal asymptode will come. In that case, what you have to do first is one simple step, find the maximum power. Here what is the maximum power? Minus x squared. And find the maximum power in the denominator, x squared. Divide it, minus 1. So here horizontal asymptode y equal to minus 1. Very simple one. Okay, minus x squared over x squared. If it is fraction comes, apply this one, y equal to minus 1. And then the second one, I already told you, in the domain, here after factorized, x minus 2, x minus 1, x 1 minus x will be there. This if you cancel here, minus will come. When x is equal to 2, it is not defined. So the question number 2, y equal to minus 1 is horizontal asymptode, x is equal to 2 is vertical asymptode. Note it down. Question number 1, there is no asymptode, none. Question number 2, x minus x squared over x squared minus 3x plus 2 over x squared minus 3x plus 2. Horizontal asymptode y equal to minus 1, vertical asymptode x is equal to 2. Horizontal asymptode, how you found out? Just to find the maximum power of take out minus x squared over x squared. If you divide it minus 1, you will get it. That is y equal to minus 1. X is equal to 2, how you got it? You factorize x minus 2, x minus 1. X minus 1 will be cancelled with the numerator. So when x is equal to 2, it is undefined. So this is the vertical asymptode. Okay. Question number 3, x minus 4 whole cube. This asymptode is none. If you substitute when x is approaching infinity, f of x is also approaching infinity, none. Question number 4, very interesting question. X over square root of x squared plus 1. X over square root of x squared plus 1. here fraction came. If the fraction came, there will be mostly horizontal asymptote will be there. Okay, but here the highest power is x. Here highest power is x square, but it is in square root. So x over square root of x square. So it is nothing but same x over x only. But here plus or minus 1. If it is x over x is only 1 only. If it is under square root x squared, it means it will be y equal to plus 1, y equal to minus 1. Note it down for this case. X over square root of x squared plus 1. Note it down. Question number 3 and 4, note it down. Question number 3, asymptode is none. Question number 4, y equal to 1 and y equal to minus 1. Okay. Question number 5, 2x squared over x squared minus 1. What I said earlier, if the highest power take out 2x squared over x squared. The coefficient will be 2 over 1. So 2 is horizontal asymptote. So y equal to 2. If we factorize x squared minus 1, x plus 1, x minus 1, so vertical asymptote is x is equal to plus or minus 1. Note it down. Question number 6. X squared over square root of x plus 1. Here vertical asymptote is x is equal to minus 1. Here, even though it is a fraction, but here higher power. Higher power means in general there won't be no horizontal asymptote. Here when x is equal to minus 1, denominator will be 0, so it is undefined. So x is equal to minus 1. This is vertical asymptote. You note it down. Even though it is fraction, there is no horizontal asymptote. Question number 7. X e power x. I already told you if it is e power x means like this will come. So y equal to 0. That is x axis is the asymptote. Horizontal asymptote is y equal to 0. There is no vertical asymptote. Question number 8. Cos x plus 2. Cos x over 2 plus sin x. Denominator cannot be 0 because sin x cannot be less than minus 1. Sin x maximum minus value is minus 1. So 2 minus 1 is 1. So this cannot be, denominator cannot be 0, so it is defined. So what is this? No asymptote. Question number 9. Ln 4 minus x squared. It is an interesting sum. Ln 4 minus x squared. What will happen? This should be positive. 4 minus x squared should be positive. Then only ln will have the values. So 4 minus x squared equals positive means it is greater than 0. 4 is greater than x squared. So x squared is less than 4. When x squared is less than 4, x value will be minus 2 to plus 2. When x squared is less than 4, it is minus 2 to plus x value is in between minus 2 to 2. So what the value will be there? Horizontal vertical asymptote, x is equal to minus 2, x is equal to 2. Note it down. Question number 10. Note it. Question number 10. X cube over x squared plus 1. Okay. Here what is there? X cube is more power. So there will not be no horizontal asymptode. Vertical asymptode not at all possible because it is always denominator will be positive because x squared is positive and plus 1 is also positive. So it is not possible. Then choose another option, x cube plus x squared plus 1. Do it in long division. What will happen? X cube, okay, will be 0. So x cube plus x. So it will be minus x will be there, right? So how to x cube over x squared plus 1, how to represent? X minus x by x squared plus 1. Okay, x minus x over x squared plus 1. This is y. Now just you bring it here. X cube over x squared plus 1 minus x is equal to minus x by over x squared plus 1. As per the limit rule, you divide by x squared highest power. So minus x by x squared over x squared plus 1 over x squared. So what will happen? Minus 1 over x plus 1 over x squared. Okay, when x is approaching, as per the slant asymptode, when x is approaching infinity, y minus x is becoming 0. This is y minus x. This will, what will happen when x is approaching infinity? It will be 0. 0 by 1 plus 0, it is 0. So this is y minus x is 0 when x is approaching infinity. So it is called slant asymptode. For example, this curve will look like this. Okay, when y minus x, when x is approaching infinity, y minus x will become 0. We will see this full video, full explanation when on my 8th video how to sketch the curve. I explained all the concept with only 10 examples, but this asymptode concept I would like to explain with more 6 examples more. Please note it down. Okay. Horizontal vertical asymptode lesson only. I am explaining with more examples. Okay, this one I already told you, if the numerator and denominator highest power is x over x is equal to 1. So horizontal asymptote is y equal to 1 and x is equal to 0, vertical asymptote. Because denominator at x is equal to 0, it is undefined. Okay, then the second one, even though it is a fraction, denominator cannot be 0 because x squared plus 9. But I told you x denominator is higher power means y equal to 0. Numerator is x, denominator is x squared. So y equal to 0. Always note down. Here also the same. X minus 1 over x squared. Denominator is higher power. So y equal to 0. Note it down. This is the horizontal asymptote. Vertical asymptote at x is equal to 0. Here x minus 1 at x is equal to 1. Okay. At x is equal to 0. Another next example, sin x over 1 plus cos x. Here denominator can be 0. Cos x value can, if it is come down to minus 1, denominator will be 0. So cos x is equal to, when will cos x will come to 0 minus 1? Cos x is equal to by, when it is by. So 180 at 180 degree it is minus 1. Cos 180 is minus 1. So the vertical asymptote is x is equal to, it will come 180 degree, then 540 degree, then 900 degree. So it will go in alternate. So 2n plus 1 pi. We are listing the vertical asymptote is 2n plus 1 pi. Then question number 16, square root of 1 minus x squared by x. This is little typical sum. There is no horizontal asymptote. Here minus x squared is minus x squared. No horizontal asymptote. Vertical asymptote is at x is equal to 0. I repeat, y equal to x over x minus 1. X by x the highest power equal to 1 coefficient. So y equal to 1 is horizontal asymptote. X is equal to 1 because x minus 1. X minus 1 at when x is equal to 1 it is undefined. So x is equal to 1 is what is called vertical asymptote. X over x squared plus 9. Denominator is higher power. So if the denominator is higher power, horizontal asymptote y equal to 0. Okay. Here also same. X minus 1 over x squared. Here denominator is higher power, x over x squared, so y equal to 0. Since x squared equal to 0 means vertical asymptote x is equal to 0. Sin x over 1 plus cos x is equal to 2n plus 1 by y, because 1 plus cos x can be 0. Previous question we have seen 2 plus sin x something in the denominator. That can never be, denominator will be 0. Okay, then question number, last question, square root of 1 minus x squared over x. Here x squared, even though in the numerator it comes 1 minus x squared. So there is no horizontal asymptote. Vertical asymptote will be x is equal to 0. Okay, note it down. See you my other lessons about intervals, concavity, local maximum, minimum, and finally I compiled how to draw all the with the 7 points. How I am explaining how we can draw the 10 examples. We can sketch the curve. Okay, see you in my next lesson.